Alrighty, this is Jerry Diamond with How to Get Out of Babylon. This is part 2 of my homegrown do-it-yourself experiment. I got cigarettes stuck in the holes there. Easy way to smoke it up. So now I can kind of see the laser beam. Okay, so let me move that over a little bit. Alright, so there's our globe. Alright. So I'm going to start at a high angle on this side of it. Now, obviously, given this scenario, I can hit the other side from here, but it's still going to give you a weird, let's say the sun was 93 million miles away. Ha, ha, ha. We're going to go into that. Pythagorean theorem proves that totally incorrect. So on this side of it, okay, I'm hitting on the near side. You can see that. So I'm going to put the camera in there. And we'll get an idea. I've got it about a 45-degree angle. Okay. So that is hitting. See, I can't quite see the reflected laser. I can see the laser on this side, but not on the other. So it's hitting about 10, 12 inches up. Okay. So now let's, I gotta watch let's move that light on the other side, just so I can get some ambient light in there. You can kind of see what's going on. All right, now I'm going to bring it down to about 30 degrees, and it is lower. So I'm not going to try to hit it 20 degrees, and it's lower. Still way up in the air though. I mean, it's a lot higher than what I'm aiming it at. And then I'm going to bring it down to, let's say, it's just barely over the horizon. And you see where it's hitting there, okay? So one of these little reflector mirrors is a good way to do this. See that? Now if I bring it down to just right at horizontal horizon, it's still way up in the air, okay? That's what it'd be doing. Don't care how big your surface is of the earth, it's still going to bounce up into the air, space, whatever you want to call it. Now, like I said, if the sun were 93 million miles away, I could hit on the far side of there. I think you can see that. There's a false image, which is actually what's picking it up off of the wall. Okay. See that? I'm at, let's say I'm at, start back up at 45. See how low that is? Okay. And then as the sun sets, I'm trying to hold it right at the edge of the mirror. See, it's coming down, but very slowly. And it's hard now. I see at this point, I can't even hit that far side. See, I can hit center, but I cannot hit anything on the far side of that mirror. I'm just shooting straight across the top there. See, and there you can see the infinity. See that, the streak there? That's what would be happening. Okay, I'm hitting many places through the surface of that mirror, and the sunlight would actually be split and diffused or diffracted into multiple places. You would not have a glow to your feet. Okay, so again, see, I'm at 45 degrees now, and you see where it is? It's right on the wall there. Actually, the higher it goes, it probably would get lower to the ground because it's hitting it at a more acute angle. See that? I can't go any higher because I've got the box there holding smoke in, which isn't really helping a lot. You can see a little bit. Yeah, you can see a little bit of the laser. So you see, this just totally blows the sphere out of the water. There is no sphere out there. Sorry, but you know, this absolutely nails it. And it's a simple experiment anybody can do. You can use a, you know, like I said, a thing like that, or you can get a, rig like that. Okay. Here's the cool thing about it is, I got 3 of those for $12. And what I'm going to do is I'm going to cut one of them up into like playing card size pieces, or even business card. You can carry that in your wallet or in your purse. Anytime you see a scene like that, you can just whip it out and say, look, watch this. Okay, and here's the deal is, this was what originally got me onto this, or, you know, got to thinking about a way to show this. Is that you've got a sunset right there, and you have somebody put their fingers, this is what I've been trying to get across to everyone. Let me pull that out and pull this off and get the cardboard out of there. Okay. Thank you, Haley. There's the little guy standing with his feet on the seashore. And the sun, as it sets, is shining on the surface of the water. Right to his feet the whole time. Doesn't stop. Flat surface. Look at a puddle on a flat street. You can see headlights in it. It's flat. If it was curved, and water's never curved, it wouldn't do that. Okay? So now, and I wish I could, maybe I could use the laser to show that. Okay? And you really can't use a laser because it's so directed, but as it's coming down, you know, it's still shining right at him. Okay? No matter what angle it is, it's going to be, some of that light is going to be seen at his feet. Okay? So now you change that to a globe, and this is easily done. Voila. Easily done with a few push pins. And I could have put my cardboard thing back in there, kind of set up. But so at this point, there's your curved surface of the earth. And like I said, there is no way, given any, you know, common sense, reality, basic science, that this light is going to get anywhere past halfway and cause a reflection all the way to his feet and to his eyes. No way can it go past halfway once it's down, you know, the setting sun. No matter if it's 93 million miles away or not, it ain't going to get past halfway. Okay. Okay, and just to point out, the curvature there, and let's say it's only 4,000 miles. That's the radius of the Earth. From a high altitude, the sun could be seen for quite a distance. I don't care. You know, well, across the United States, when it is, this is another proof, the Pythagorean theorem, when it's noon on the East Coast, the sun is directly overhead. This is on a day when the sun rises at 6 and sets at 6, okay? 12 hours in daylight. Know you now that you have 12 hours of daylight. Gee. Okay, so at noon, it's directly overhead the East Coast. At 3 hours later, it's at a 45-degree angle, and it's over the West Coast 3 hours later. Okay? East time, Central time, Rocky Mountain time, Pacific time. All right? So it's at noon on the Pacific coast, it's directly overhead. 3 hours later, it's setting, and you have a 3,000-mile long path that it has traveled. So let's use that 3,000 miles I did 4,000, but I'm going to redo it. Okay. You take, let's clear it. I'm not used to this one. I'm used to my phone. There's the big C, clear. Okay, 3,000. Clear X, okay. Times 3,000 equals 9 million. Okay, times the magic number that they give us for the globe, 0.666. You would think some believers would wake up with that one. That is the fact. 8 divided by 12 is 0.666, okay? So now we got to divide by 5,280. That gives you the answer in feet. 5,280. 1,135 miles of curvature should be in play, okay? So across the United States, there should be 1,000 miles. What's the tallest peak on the, let me double check that just to make sure. Okay, 3,000 miles. I mean, it's just so unbelievable that it's absurd. 3,000 miles times 3,000 miles equals 9 million, okay. Multiplier times 0.666. Okay, and that equals 5,990,500 whatever. So it's two-thirds of our original answer. Okay, and then divide by 5,280 to get our answer in our American way of life, speech, figure of speech, number, whatever, nomenclature. Okay, so we across the United States, we should have 1,135 miles of curvature. There should be a peak, Kansas, Nebraska, somewhere there, of 1,000 miles. Do you have that? I don't think so. What's the tallest mountain in the world, people? Mount Everest, 29,000 miles, 29,000 feet, 6 miles, ballpark, not even. Okay, 1,000 miles of curvature. Missing. Okay, so across, what I'm getting at is from Hawaii to the setting sun across the Pacific Ocean, you have a hellacious, let's say it's only that, 1,000 miles. So for 1,000 miles beyond that midpoint of the peak of the curve of the Earth, you would have zero light. You would be in darkness. You would not have any reflection of light to your feet, touching your little toes, touching the seashore, which you do have in reality. I think I've belabored this point enough, but since I have 2 minutes left, let me say a little bit about the Pythagorean theorem. At noon, East Coast, suns are overhead. At noon, West Coast, suns overhead 3 hours later. And given the Pythagorean theorem, the sun is now at a 45-degree angle from the East Coast. And so you know from simple geometry that all angles have 180 degrees. 60, 60, 60 in an equilateral triangle. Well, now you have 45 degrees. You have a 90 from the sun directly overhead, and on the west coast, a 90-degree angle. That leaves exactly 90 degrees in your total of your triangle. Subtract 45 from 90. What do you have? 45. You now have both legs must be equal of your triangle that you have. So your angle from the sun to Boston, or from the East Coast to directly across the land, is 45 degrees. The angle from the West Coast up to the sun and across to the East Coast is 45 degrees. Those legs must be equal. We're talking ballpark 3,000 miles. Pretty simple. When I saw that, I was blown away. I said, I know geometry. I understand that perfectly. There is no escaping that. It is perfect, solid, unbreakable. You can't dispute it. You can't argue with it. End of story. A squared plus B squared equals C squared. Pretty close to 3,000 miles. So this is Jerry Diamond with How to Get Out of Babylon and Flat Earth Homeland. If you're listening to this, you are the remnant. Thank you very much.